Hello viewers, welcome to my channel Online Biology Tutorials. In this live of today, I will be reading chapter 11 Light, Shadows and Reflections taken from the Curiosity Book of Science class 7. In case you are interested in hearing the audio of first 10 chapters, you can visit the playlist on my channel. As the screen is clear, let's go ahead with the reading of chapter 11 Light, Shadows and Reflections. In the Western Ghat region of Maharashtra, Keshav spends part of his summer vacation at his friend Jatin's grandparents' village. Having lived in a big city, he finds the forest, fresh air, sounds of gushing streams, and chirping birds a novel experience. However, for Keshav, the most fascinating sight is the dance of hundreds of fireflies at night, flashing their lights in a wonderful performance. Jatin's grandparents explain that fireflies are seasonal insects and they use light to communicate. Unfortunately, Keshav also learns the number of fireflies is decreasing due to light pollution, reduced forest cover, and excessive tourism. At the end of their vacation, Keshav and Jatin board in an evening bus back to their city. As the bus winds through the hilly roads, Keshav watches the moonlit landscape and the beams from the headlights of passing vehicles flashing by. He is reminded of the many poems and songs about moonlight and wonders. Does the moon actually produce its own light? Did we not learn in the chapter Beyond Earth in the grade 6 science textbook Curiosity that all other objects in our solar system shine only by reflecting the light of the sun? Is moonlight just reflected sunlight? Which objects give off their own light? While thinking, he notices something strange. Light seems to move in a straight line. So let's see what are the various sources of light. Sun gives out or emits its own light and it is the main source of natural light on the earth. Stars, lightning, natural fire and certain animals also emit their own light. In ancient times, humans learned to create fire, the earliest form of artificial lightning. With time, they learned to create fire using different fuels such as animal fat, oil, wax, and gas. With the invention of electricity and different kinds of electric light sources, most of the lightning needs of humans are now met by electric lightning. Objects that emit their own light are called luminous objects. Objects that do not emit their own light are called non luminous objects. The moon is a non luminous object. It does not emit its own light, it just reflects the light emitted by the sun that falls on it. So, some natural light sources of light are shown to you here. Fire as a source of artificial light can be used in a lamp in this mashal like structure, diya, and candle. These are the sources of electric light. Science and society. Light emitting diode or LED lamps are modern light sources that consume much less power, are brighter, and last longer than traditional lamps. This not only reduces electricity bills but is also better for the environment. Recognizing their advantages, the Indian government has made substantial efforts to promote the use of LED lamps nationwide. At their end of life, LED lamps must be appropriated, disposed, or recycled and not thrown in the garbage. Does light travel in a straight line? Let us do an activity to try to find out. Activity 11.1. Take three matchboxes, make a hole in the inner tray of each matchbox exactly at the same position. Arrange these three matchboxes in a straight line. Make sure that all three holes are exactly at the same height and are in a line as shown to you in figure 11.4. So this is how holes are to be made, and this is the screen and holes at the same interval, and then a torch light has been placed on the front box. Let's see what is written here. Place a torchlight on one side of the matchboxes, ensuring that its lamp is at the height of the holes. Place the cardboard or screen on the other side of the matchboxes and obtain a bright spot on it. You may need to slightly adjust the heights of the boxes. Move one of the matchboxes slightly to a side or up and down. Are you able to obtain the light spot on the screen now? When all the three holes are in the same line, we could not obtain the light spot on the screen. These observations suggest that light travels in a straight line. Can we somehow check it in some other way? I have an idea. Let us try to see the candle flame through a bent pipe. Should we also try out this idea? Activity 11.2 Caution. Use a lighted candle under adult supervision only. Take a long hollow pipe of some flexible material and align it so that you can see the candle flame as shown to you in figure 11.5a. So here you can see that girl is holding a pipe and she is able to see the flame. Now bend the pipe and try to see the candle flame again as shown to you in 11.5b. Can you still see it? You could see the candle flame through the straight pipe but not through the bent pipe. This shows that light travels in a straight line. Dive deeper. Caution. Use a laser only under teacher's supervision. Avoid using high powered lasers for this activity. A low powered laser pointer is sufficient. Never point the laser beam directly at anyone's eye as it can cause serious eye damage. Pass a laser beam through a beaker filled with water in which a drop of milk is added to make the laser beam easily visible. What do you observe? Do you see the beam of laser light inside water follows a straight path? However, light can sometimes even bend around corners. This is something you will learn in the higher grades. Light through transparent, translucent, and opaque materials. What happens when an object comes in the path of light? Let us place objects made of different materials in the path of light and find out. Activity 11.3 Collect objects made of different materials. Also, you will need a torch. So, you need to find for cardboard, paper, glass, tracing paper, thick cloth that whether they are transparent, translucent, or opaque, and light is passed through them either fully, partially, or not at all. So, this is your prediction and this is your observation. Predict means you need to write answer first and then you need to see actually whether it is allowing your prediction was correct or was it a failure. List the materials of the objects in table 11.1 and classify them into transparent, translucent, and opaque in the chapter Materials Around Us. In the grade 6 science textbook Curiosity, you learn to classify materials into transparent, translucent, and opaque depending on how you could see through them. Go to a dark room, turn on a torch, and place it in such a position that you get a spot of light from the torch on a wall. Or you may place a cardboard screen as shown in figure 11.6 and get the spot of light on it. We will now conduct this activity in two parts, prediction and observation. Predict what will happen if you hold an object in front of the light coming out of the torch. Would you continue to see the spot of light on the screen? Note your prediction in table 11.1. Now actually place the object between the torch and the screen. Does light pass through the object? Note your observation in table 11.1. Repeat this for all the objects. Was your observation the same as your prediction? What conclusions do you could you draw? Light passes almost completely through transparent materials. Light passes partially through translucent materials. Light does not pass through opaque materials. What happens when an opaque object, blocks the path of light? 11.4 Shadow formation. What did you see on the screen in activity 11.3 when an opaque object was placed in the path of light? Did you see a dark patch on the wall? Why was this dark patch formed? We now know that light travels in a straight line, so when an opaque object is placed in its path, light is blocked. The dark patch where light does not reach is the shadow. We have noticed shadows of ourselves and other objects around us when we are in the sun or under a light. Also, you might have had fun making different shapes with shadows sometimes. Do translucent and transparent objects create shadows or not? Did you notice that activity in activity 11.3 opaque objects form darker shadows, translucent objects make lighter shadows, even some transparent objects can create faint shadows. Let us learn about more about shadows. Activity 11.4 collect some opaque objects of different shapes and sizes. You need to repeat activity 11.3 but this time carry out the actions mentioned in the first column of table 11.2. Observe the shape and size of the shadow on the screen for each of the actions. Did the shadow form in all cases? Was the shape and size of the shadow the same as the object? Record your observations in the second column in table 11.2. So what actions you need to do? The screen is removed, the object is removed, the torch is switched off, the object is moved closer to the screen, keeping the torch and the screen fixed. The object is moved closer to the torch, keeping the torch and the screen fixed. And the object is tilted, keeping the torch and the screen fixed. The color of the object is changed. What conclusion do you draw from this activity? What do we need to observe a shadow? Does the color of the shadow change when the color of the object is changed? Shadows are found when an object blocks light from falling on a screen. We need a source of light, an opaque object, and a screen to observe a shadow. The walls, floor, ground, or any other surface acts as a screen for observing shadows in our daily life. The shape, size, and sharpness of the shadow depends on the position of the object relative to the light source and the screen. The shadows may give information about the object or we may not be able to guess the object at all. Changing the color of the opaque objects does not change the color of the shadows. Fascinating facts. Shadow play or shadow puppetry has been a part of our cultural heritage for centuries. In this art form, flat cutout figures called shadow puppets are placed between a light source and a screen. By moving the puppets and the light, puppeteers can create lifelike movements, bringing the characters to life. Different regions have their own unique styles, like the Charma Bahuli Natya in Maharashtra, Kilu Bomi and Tholu Bomalata of Andhra Pradesh, Tugalu Gombeata in Karnataka, Ravna Chaya in Odisha, and Thol Pavakuttu in Kerala, and Boma Lattam in Tamil Nadu. These are used not only for entertainment but also communicate important messages to the society. Reflection of light. When an opaque object was a shiny object like a polished steel plate, I got a shadow on the screen, but I also saw that there was a bright spot of light on the wall on the opposite side. Why was it so? Activity 11.5. Find a shiny, flat steel plate or a plain mirror that is a mirror that is flat and not curved. Take it outside and let the sunlight fall on the shiny surface. What can you do to redirect light on the wall on which the sunlight is not falling directly? Turn the shiny plate or mirror in different directions to redirect the light onto a wall or to a nearby surface. Do you see a spot of light on the wall? Does it mean that the shiny plate or mirror has changed the direction of light? Now tilt the shiny plate or mirror in different ways and observe the light spot on the wall. Does it change position? Notice how light always travels in straight lines and changes direction when it falls on the shiny plate or mirror. What conclusion do you draw from your observations? This activity suggests that a shiny surface of a or a mirror changes the direction of light that falls upon it. This change in direction of light by a mirror is called reflection of light. Let us try to understand the reflection of light by a mirror. Activity. Take a plain mirror with stand, a torch, a comb, a sheet of white paper, and a strip of black paper. Using the black paper, close all openings of the comb except for one to make a thin slit. Spread a white paper on a table, hold the comb perpendicular to the sheet of paper, and shine the torchlight on the slit. Adjust the comb and torch slightly till you see a thin beam of light along the paper which has passed through the slit. Now pass the mirror in the path of the light beam while keeping the comb steady. What do you observe? The path of the light beam is changed after falling on the mirror. The reflection of light occurs on the mirror. In a mirror, I can also see my face. Is that also due to the reflection of light? Images formed in the plane mirror. Similar chapter you will be reading in class 10th as well. Look into the mirror. Do you see your face in it? What do you see is a reflection of your face in the mirror. We also see reflections of other objects that are in front of the mirror. Let us try to find out more about this. So, activity 11.7, take a plain mirror and a pen or some other object. Place the pen in front of the mirror as shown to you in the figure 11.10, this one. What do you see in the mirror? It appears as if a similar pen is placed behind the mirror. The pen which appears behind the mirror is the image of the pen formed by the mirror. The pen itself is the object. Now move the pen to different positions in front of the mirror and compare the sizes of the images of the pen at different positions. Are the two sizes same? The image formed by a plane mirror is of the same size as the object. Again, move the pen to different positions in front of the mirror and observe if the image is upright at each position. Does the tip of the pen appear on top of each position? An upright image is called erect. An image formed by a plane mirror is always an erect image. Now place a screen vertically behind the mirror. Move it around. Do you get the image on the screen? Repeat this by placing the screen in front of the mirror. The image formed by a plane mirror cannot be obtained on a screen. Activity 11.8. Stand in front of a plane mirror as it is shown to you here and look at the image as seen in 11.11. Notice how far it appears to be from the mirror. Now stand closer to the mirror. Is the image also closer to the mirror? Stand at different distances from the mirror and notice how far the image appears to be from the mirror in each case. Do you find any relations between your distance from the mirror and the distance of your image from the mirror? So here, observe one own image in a mirror. You might have noticed that when you stand closer to the plane mirror, the image also appears to be close to the mirror. The image appears to be far from the mirror when you stand far from the plane mirror. Raise your left arm. Which arm does your image raise? Touch your right ear. Which ear does your image touch? You find that your left appears right in your image and your right appears left in your image. This type of perceived left right reversal is called the lateral inversion. There is lateral inversion in the images formed by a plane mirror. Oh, now I realize why ambulance is written on a reversal way in an ambulance. It reads ambulance when viewed from the rear view mirrors of the vehicle ahead of the ambulance. Fascinating facts. When mirrors were inverted, it is not known. When mirrors were invented is not known. Earlier mirrors were made by polishing stone or metal. When glass mirrors started being made, the art of making metal mirrors got lost gradually. However, it still survives. For example, in Kerala, where Aranmula Kannadi, a unique metal surface mirror, has been made for centuries. Can we see an image of an object only in a mirror, or are there some other ways as well? Pinhole camera. A pinhole camera is a device in which the light rays from an object pass through a tiny hole or a pinhole and forms an image on a screen. Caution: use a lighted candle under adult supervision only. Take a piece of cardboard and a candle. Make a small hole in the cardboard. In a dimly lit room, position the cardboard at a short distance from a screen. Place a lighted candle in front of it as shown in figure 11.12a. What do you see on the screen? Light coming from the flame passes through the hole on the cardboard and forms an image of the candle flame on the screen. Do you notice anything surprising? The image of the candle flame is upside down, that is inverted. Let us now make a pinhole camera which you can use outdoors. Activity 11.10. Take two boxes of cardboard such that one can slide into another with very little gap in between them. Cut open one side of each box. On the opposite face of the larger box, make a small hole in the middle. On the opposite face of the smaller box, cut out a square from the middle of a side of about 5 to 6 centimeter. Cover this opening with a thin translucent paper like a tracing paper to form a screen. Slide the small box inside the larger one in such a way that the side with the tracing paper is inside. So whatever they are saying, you can refer to these images as well. Hold the pinhole camera with the pinhole facing the object and look through the open side of a smaller box. Cover your head and the camera with a dark cloth. Look at a distant object like a tree or a building in bright sunlight and move the smaller box forward and backward until an image appears on the tracing paper. Do the images seen in the camera shows the color of the objects on the other side? Are the images erect or are they upside down? Dive deeper. A pinhole camera gives an upside down image. On the other hand, there is lateral inversion in the image formed by a mirror, but it is not upside down. We will learn more about this in higher grades, making some useful terms. After having learned that light travels in a straight line and is reflected by mirrors, it is time to create some useful items based on this learning. Periscope. We can make a small periscope by placing two plane mirrors in a Z or Z shaped box as shown to you in figure 11.14. This one, reflection from two mirrors enables us to see objects that are not visible directly. Periscopes are used in submarine tanks or by soldiers to see outside their bunkers. You may use it to look ahead when standing behind taller friends. Kaleidoscope. Get three rectangular plane mirror strips of equal width and join them together in a triangular manner as shown to you in figure 11.15a. You may use three strips of thick reflective paper instead of mirrors. Fix these in a circular tube of thick chart paper. On one end of the tube, fix a transparent plastic sheet using a rubber band or an adhesive tape. Place several brown pieces of colored bangles or beads on this and cover it with a tracing paper using a rubber band or an adhesive tape. When you peep through the open side, you view a beautiful pattern, even if you leave both sides of the kaleidoscope open and point it towards a tree or other objects. You see beautiful patterns. An interesting feature of the kaleidoscope is that one always get to see a different pattern every time the kaleidoscope is turned about. Since there are three mirrors and multiple images due to reflections of reflections, many interesting patterns are formed. Designers and artists often use kaleidoscopes to get ideas of new patterns. In a nutshell, objects that emit their own light are called luminous objects. Light travels in a straight line. Light passes almost completely through transparent materials. Light passes partially through translucent materials, and light does not pass through the opaque materials. A shadow is formed when light is blocked by an object. Opaque objects form darker shadows. Translucent objects make lighter shadows. Some transparent objects can create faint shadows. The change in the direction of light by a mirror is called reflection of light. The image formed by a plane mirror is of the same size as the object is erect, cannot be obtained on a screen, and is laterally inverted. A pinhole camera creates an inverted image of an object on a screen. So these are the questions. Let us enhance our learning. You can pause the video and practice these questions on your own. Here is another set of questions for you. Once you are done with this chapter at your school, you can definitely practice. And this is the another set of questions. You can also go ahead with the exploratory projects in case you are interested in. We have few exploratory projects here on this screen as well. I hope the text is clear to everybody. You can pause the video and you can practice. Fascinating facts. Light emitted by the sun takes about 8 minutes and 20 seconds to reach the earth. Hence, if the sun were to suddenly stop emitting light, we would not know that for another 8 minutes and 20 seconds. Quite an interesting fact. So, with this, we are done with the reading of chapter 11, Light, Shadows, and Reflections. This is chapter number 11, taken from the Curiosity Book of Science. In case you are interested in hearing the audio of first 10 chapters, you can visit my playlist and you can subscribe if it seems helpful to you. Please share it with your friends. Stay connected. See you in next live. Thank you.